This is how we, start. Yeah, howdy. Something new to you. Thank you so much for coming to our second, technically, second, but third laser talks at Texas A&M University. I'm Giselle Hayam-Seo, a director for the Institute for Applied Creativity. We're the main hosts for this event. We have collaborators you see here, sponsored by also College of Performance, Visualization and Fine Arts, as well as Center for Humanity Research, and also the Art Gallery as well. Okay, so the main introduction will be done by Dr. Peter Taj. Thank you so much.
Welcome everyone. Please enjoy snacks. Please enjoy the talk today. This talk is a part of the Leonardo Laser Series, an international organization based on a publisher at the intersection between arts and sciences in the spirit of Leonardo da Vinci. So let me tell you a little bit about our speaker today. Joost Rechtevel is an artist who wonders what humans can learn from a dialogue with the machines they have constructed. In a form of media archaeology, he investigates modes of material engagement with devices from forgotten corners in the history of science and technology. The outcomes of these investigations often take the shape of abstract films that function like alien anomalies. In their sensuality, they are an attempt to reach an intimate and embodied understanding of our technological world. His films have been shown worldwide in a wide range of festivals and venues for experimental film, animation, or other kinds of moving image. He realized several installations and did many collaborative projects involving composers, music ensembles, theater companies, and dance companies. Since 1990, he has been putting together many film programs. He curated several exhibitions, and he occasionally publishes essays. He has been giving lectures since 1993, has been teaching since 1996, and from 2008 to 2014, he was the course director of the Art Science Interfaculty of the Royal Conservatoire of the Royal Academy of Art in The Hague. Since 2017, he has been affiliated with the School of Arts University in Ghent as an artistic researcher. Ladies and gentlemen, please welcome Joost Rechtevel.
Wow, what an introduction. Thanks. Well, I'm very excited to be here. Thanks very much to the Institute of Applied Creativity for inviting me. I have to speak in the microphone, so please look annoyed if you can not hear me. I'm going to be talking about machines and a kind of artist relationship to machines, my particular relationship to machines. So what I want to do is first talk about tool building as an artist, and then I explain also a little bit what I mean with this idea of a dialogue with machines, which Lynn introduced. Then I will talk about a film project I realized over the past, depending how you count, 8 years. And then I will finish with a more philosophical reflection, which is something I will read as a text, because I think it's better as for the precision of it. But before we start, I just want to show, I'm not going to show much of my work. There will be stills, but I want to show a film I made which is 1 minute as a kind of introduction, that we know a little bit what it is we're talking about. So I'm going to conjure that up on the screen. Oops. All right, I can just play with this. Okay, so that's a very short piece. There was a gremlin touching that pad 2 times during it, I don't know why, but we'll talk about gremlins later. So that was very appropriate. There's a lot of gremlins in this thing. Oops. Okay. So before I begin, I would like to start with a quote. And it's a quote which really captures, I think, some really essential aspects of how, also what my relationship is with machines. And it's a quote from Nam June Paik, one of the pioneers of video art. I guess some of you know him very well. And it's from an interview from the early 70s. And the question is, but you must get some pleasure out of what you do. Is it subverting technology? And then the answer is, yes, in a way. I am always overwhelmed by my engineering. My TVs are more the artist than I am. I can compose something through technology that is higher than my personality or lower than my personality. In painting, you can compose as much as you want, but de Kooning cannot make anything that is deeper or more profound than what he has inside himself. But in engineering, there's always the other. The other, it is not you. Your work is not yourself. Sometimes your work had nothing to do with yourself. So it's a bit of a cryptic quote, but I like it very much. I mean, I can really recommend listening to interviews with him. He's hilarious, but he's also very profound. So I will explain in my talk, the aspects, which really resonate for me with my own practice.
Do you mind speaking a little bit more louder?
Yeah.
That'd be great.
I'm sorry. So where does this go? Look, so what you saw is that I make abstract images, and for me that really started with the idea of visual music. And one of the things in visual music which I found really interesting is not only the connection between thinking about music and thinking about moving image, but also the thinking about, so not only thinking about, what could visual music be, but also thinking about the instruments. Like in classical music, these instruments already exist. They have been sort of given to us from the ancients, like these instruments are mostly very old already. But in visual music, these instruments do not exist. So there is this tradition of visual music which has this aspect which I find very interesting, is that you have this tradition of people thinking of ways, how can we actually make an instrument that we can play visual music in real time. So it's not a music with sound, it's a music which only consists of images, but which has the same kind of emotional impact, or which may have the same temporal structures, or similar. So that's a rabbit hole. I can talk about it for very long, but we only have 30 minutes. And the only thing I want to mention now is this idea of instrument building. Because instrument building is not just a means to an end, it's also defining what this visual music then is, because it will define what you can actually do. So this is Alexander Wallace Remington. I'm just picking 2 random examples from this history. He was a British landscape painter, and around 1910 he invested the whole capital of his, he was from a wealthy family, in these beautiful instruments. And they're really like organs, but instead of producing sounds, if you press the key it would produce a colored light projection. Another example is Mary Helle Greenewald, who was American. She was an amazing woman. I mean, she had all kinds of ideas about the art of light, which she called Nur Atar. She was raised in Syria as the daughter of diplomats, but she was also an engineer, which she's a bit later, 1920s, so she has patents on all kinds of devices which can produce visual music. So this looks a bit like a record player, but in fact what it does, so it also has grooves and a needle which scans these grooves, but the grooves do not encode sound, but the grooves encode a temporal composition of color, which is then played in this ball. So it's a kind of lamp which changes color, but according to a very precise composition which she made before. She also designed interfaces to play this music, so she invented also like color organs. And she designed the notation, and she had a whole practice. This is a rabbit hole, I'm already talking too long about this, but for me the point I want to stress is this point of the visual music being one of my interests or triggers to start making abstract films, but also this point of instrument building, that it's defining what you can then actually do, like what is this music. So this is her playing her instrument. So that brings me to this idea of dialogue. I'm not a graphic designer, so this is a very crude symbol for dialogue, like it goes in two ways. Most ideas about technology are functional, and it makes lots of sense in almost all circumstances, and the idea is that you want something and you build a machine to do it for you. So you don't want surprises. In arts, that's very different. And one of the things I started realizing when I was building my own tools to make my films is that I was actually really interested if there were surprises, because very often these surprises were more interesting than what I had already in my mind, or at least it questioned what I already had in my mind. So that's where this dialogue with machines comes. And for me, this dialogue, like a very important part of my practice, happens in the studio, where I build this device, I do experiments, and then I adapt the experiment of the device to the outputs. I evaluate, I get inspired. So this is a process. The building of the tool I will use to make the film is coincides with developing the idea, with developing a certain language, developing a certain mode to think about composition of visual images. So all these things are the same process. So it's not that I first think of what I want to do and then I build a tool. The tool building is really part of my creative thinking. So that's where, what this, for me, the dialogue with machines, what that means. Like when I use this term, that's what I mean. So this is my studio still. So I will talk about what all these machines are. So partly these are historical, and partly these are machines which I built myself, inspired by this historical example. I have to check. Oh, yeah. So I talked about tool building. I introduced this idea of dialogue with machines, and now I will talk about my practice, like which machine, what are we talking about? So I've built all kinds of things. I've started building like kind of animation tools. So I made 35mm animation films. So this was all mechanical, optical. So I was essentially building devices which would, for instance, a kind of kinetic sculpture, but which was made not for the viewer, but for the camera. So that the camera and the sculpture together create images. After that, I wrote lots of code. I've made several films which are completely generated by code. And it's also a way that you make your own tools, but the tool is not hardware, it's software. And then I got really sick of sitting behind the computer and getting, like RSI and all these kind of physical problems you get when you sit too much behind the computer. And I remembered building devices, and then I got really interested in analog electronics for several reasons. Like one is that it's physical, so you're actually building stuff. Like hardware have different kinds of surprises than software. So I was really attracted to having more interactions with matter. But it also has this thing which is a bit similar to programming. Like in electronics you build circuits, and these circuits, they're in a way also kind of programming. There is this sense of structuring, configuring things. And the third part is that I really was also very interested in this history of analog electronics. So this is a picture from the 1950s when the analog tree was already very old. I suppose that most of you do not understand most of these words on this. These words are also old-fashioned. I mean, this is from the 1950s, which is a certain phase just after the Second World War, which was really important in the development of analog electronics. And I was really intrigued by that language. And I was especially intrigued by a device which is called analog computer. Sorry. And the analog computer came out of the Second World War. Like a lot of the media we have, in essence, a lot of this comes from the Second World War or from the Cold War just after the Second World War. And what happened one of the things which happened in the Second World War is that aeroplanes became too fast for humans to follow. So if a German aeroplane comes, or a missile especially, actually, they are too fast, so humans cannot actually point the gun at it. So there was a problem. So they invented radar, I mean, it's a whole story, but they also invented this strange box over there, which is called the gun director. And what this gun director does, it's a kind of computer, or it calculates, it does physics, let's say, and it calculates where the bullet should go to hit the plane in the future, because that's the tricky part. When planes go fast, you have to hit in the future. So it's a kind of predictive machine. And I'm talking about this because what was in there is a kind of analog circuit which became the basis for what is called analog computing. So this is a kind of computing which has nothing to do with the computers we have in our pockets and on desks. So it's a kind of simulation technology which uses signals and voltages to simulate physical systems. So what happened is that these circuits came out of this box which was only used in the field, and they also became part of the lab where they started simulating rockets. So you have beginning of this, so this is late 40s, like 1949, around 1950, where they started using these analog technologies to simulate the behavior of physical systems, such as missiles or submarines, all these kind of things. And this became a whole industry. So at some point, all universities around the world had these machines. So they were actually very common. And then at some point, the use sort of expanded into also non-military forms of simulation. So they really became research tools. And then also, like this is a development which mostly happened in the US, but this is the first analog computer in France, which was also very early already, end of the 40s. And then also it spread around the globe, and then also, for instance, China built these kind of machines, but then, let's say 1 or 2 decades later. So this is a whole world which doesn't exist anymore. I mean, that's also one of the reasons why I'm interested in it. Another reason is that all these devices which I show, they are the ancestors in a very direct way of the audio synthesizers you may know, like these racks with modules and cables. These are ancestors in a very direct way. The people who developed these machines, they knew about analog computing and they used it as a model. This is another example. This is an image processor by Dan Sandin from the Electronic Visualization Lab in Chicago, which is essentially the same kind of thing. And he calls it an analog computer optimized for video. So it's like a video synthesizer. So you can patch and then it creates moving images. And this is him at the time. And then there's other devices like I was in Buffalo where they have a magnificent exhibition of Steina Vazulka. And with the Steina and Woody Vazulka, they used a lot another modular analog computing device for video, which is called the RUT-ETRA processor. So this is a bit of this history I was sort of touching upon, and I was very interested by as a way also to get to a different type of programming, which is very different from using an existing video synthesizer. Because basically I will talk a little bit about it later, what these devices do, it's a bit like you have all these modules, but the modules, they do not process video, but they do mathematics. So a module adds to signals or multiplies to signals or integrates a signal. And with these 3 basic operations, you can basically do all differential equations. And then part of the audience will glaze over when I mention the word differential equations, but another part not. And actually, I don't see anybody glazing over. In an art context, if you talk about mathematics, people switch off. So I try to prevent this, but I don't see this happening. So, okay. So I was really interested in getting to the grips of it. And then my question was, like, with this kind of completely different paradigm of computing, what images would that make? Like how can you actually think about images using these kind of basic blocks? Hang on, where am I? Also checking the time. Okay. Yeah, so I basically, I removed 1 slide too many. That's a pity. Because I reenacted this picture and it's hilarious, but yeah, I don't have it anymore. Because I have the same machine, so it started by building, buying an EAI analog computer from 1963, the first desktop computer made in the world. I'm European, so I think in kilos, but you need 4 people to lift it, so it's a desktop, but you need a really sturdy desk, otherwise it will just collapse. So it started from here. And basically, I started rebuilding the architecture of this. So you see these modules. I talked about adding, multiplying, integrating. So I started building these modules, but using electronics of nowadays or more recent electronics, which means that the machine I built is also an analog computer, so it's similar, but it works like 1,000,000 times faster. which means that you can not only simulate rockets in real time, but you can also do video, which is something I find more interesting. So this is a machine built also to produce video, but according to this basic programming elements of historical analog computing, which is a science which sort of died out in the halfway the 70s. So with this I made a film. It was actually my first feature, also because I made it during COVID, and then in Belgium there was lockdown, everything was closed, and I think, well, you know, I'm just going to make a feature. Like I always made short films before this, but I also made a feature because the images are very detailed and they really need time, which is also the reason I'm not showing them to them here. Like it's a feature and it's made for the cinema, and basically what I do is try in that film is to drag people in to a universe of images which I think they will have never seen, and I also try to slow them down and make them attentive to small changes. So that's why also it's a completely abstract film of a slightly impolite length of 80 minutes. Which is, some people find it boring and walk out after 10 minutes, and other people find it an experience. And this film is about the meeting point of two things. And it's about basically it's meeting point of two things. And one thing is that when I started collecting these devices, and like this analog computer, all kinds of signal generating devices, I became aware in a very direct way that these are very high-end devices which were super expensive when they were made. I buy them now for like $40 on eBay. And this kind of high-end electronics was very specific. It was originated in a very specific context in the 60s and 70s. So basically half the devices I have in my studio, they have stickers on them from military labs. So this became something I did not expect. I make abstract films, which is a purely formal art, you could say, like music. I have a studio which is like an ivory tower. It's well secluded, isolated from the world. And then suddenly I find myself dealing with military heritage. So I was thinking, what's going on? And then I got really interested in the beginning of the Cold War, which is also the height of this simulation technology, beginning of the 60s, which is also the beginning of these big protective technological domes, which like global surveillance, which look at are the Russians or the Soviets already shooting at us. And which is the origin of a lot of our technologies. I mean, it's the moment where computers became, instead of calculators, they became real-time information processing devices, linked up across long distances, operated by people pointing at screens instead of punching codes. So you could really make a case that what we do now with a computer, what we call a computer, was actually defined at that moment. So I thought it was a very interesting point. And then the other element, which is really an important part of my film, is the discovery of chaos and chaotic systems. And there's two stories. One was with the digital computer. Meteorologist Edward Lorenz was simulating weather systems and discovered what he called the butterfly effect, which is famous. And he discovered this with a digital computer. At around the same time, there was a Japanese researcher who in 1961, Yoshisuke Ueda, who worked with an analog computer and made the same discovery. And basically this discovery is that there are systems, like if you have, I don't know if I have the equations, there are systems which have very simple equations, which sometimes also have very simple curves or solutions, but sometimes the parameters or the values are such that it sort of explodes in a kind of complexity. And what's interesting about this complexity is that we cannot predict this. We humans cannot, there's no mathematician really who can look at a set of equations and say, this is chaotic and this is not chaotic. The only thing you can do is run them on a machine, like you calculate them on a computer or an analog computer, and then some of them are chaotic. And analog computers are very good at doing chaos. So I did a lot of it. I explored lots of systems. And the film I made is basically the meeting point of these two things. I found it very poetic that at the same time there was this sort of push for global transparency, making the world completely predictable. and that within the same computing technologies there is this discovery of chaos, where that in this completely transparent, controllable devices there is inherently a kind of unpredictability which we just cannot capture as humans with our limited cognitive powers. Yeah, so these are some tests I did, and this is a still from the actual film. I'm looking a bit at the time because I'm hesitating if I should read this text. I think I will. I skip some things, we can perhaps come back to that later. So I will now come to the philosophical point connected to this, the more practical things I have talked to you about. Okay. The anthropologist Edwin Hutchins, and this is him, developed a form of cognitive ethnography around the concept of distributed cognition. In his studies of ship navigation, Hutchins shows that many of the cognitive processes that we traditionally locate inside of our heads are more appropriately located in social and material structures. The intelligence at work in steering a large ship can, for instance, not be found outside of the artifacts, procedures, and social structures that this steering involves. The crew of a ship does not consist of mathematical wizards, but of people who are trained to look at dials, consult charts, and plot courses. Cultural structures like these simplify a very complex computational problem into a series of elementary tasks. Hutchins writes, "Humans create their cognitive powers by creating the environments in which they exercise those powers." End of quote. Over the last 2 decades, the cognitive archaeologist Lambros Malafouris developed similar ideas into a coherent and complete theory of material engagement. According to him, humans have the ability to extend their bodies and transform their cognitive architecture by forming emergent coalitions with material objects. The example he gives is the image of the blind man with a stick. The stick turns touch into a form of sight, and it becomes an extension of the body and of the sensory apparatus. But such an extension should not only be understood in terms of amplification, because the extension of the body not only intensifies, but it radically changes the nature of the cognitive operations that are involved. Malafouris proposes that such reconfigurations are the source from which human thinking emerges, because thinking for him is first of all a thinking through, with, and about things, bodies, and others. Mind is a property of the coalitions as a whole, and not of individuals taken separately. Nor can it be said that thoughts are caused by individual human agency. He says, agency and intentionality may not be properties of things. They are not properties of humans either. They are the properties of material engagement. Humans assimilate their environment through a curtain of objects. This is a beautiful formulation by André Leroi-Gourhan, and it evokes the image of humans creating an intermediate space that consists of clothes, buildings, and other artifacts. According to Leroi-Gourhan, such a space forms the interface between our inner world and our planet. The human is defined by this thin layer in the same way an amoeba is defined by its cell membrane. It is its border as well as the gateway to the world. Accounts like the one given by Malafouris show how distinctions, such as between physical and non-physical, or between self and other, obscure our understanding of the processes that underlie our thinking and learning. Embracing our cyborg nature has the potential to liberate us from a superficial humanism. It points to a situation in which we are capable to understand and acknowledge our deep connection with our ancestors, contemporary humans, animals, machines, and other objects. Our thinking arises from fleeting coalitions, and we are able to inhabit many different viewpoints. As in the picture drawn by Leroi-Gourhan, the inner world, the outer world, and the boundary between them are fundamentally intertwined. Our technical milieu is an external memory, a collective human body to which each generation contributes by modifying and adding things. The design and development of our technology is therefore a form of politics, through which we collectively shape our life world and in a very direct way our planet and ourselves. In my work, I see media archaeology as a method to investigate this collective body. This paints a picture of media archaeology as a kind of reaching back, as an attempt to descend to the hidden foundations of the network of machines that surrounds us. I do think this is indeed necessary to understand these foundations and to grasp these networks. But understanding is perhaps not the end point. There's also a freedom in these machines that points in a different direction, to alternative ways of approaching them that are equally possible. As physical objects with a physical presence, machines are not exhausted by the uses and descriptions that humans make of them. All humans have a potential of, interesting. All machines have a potential that is not yet realized, partly because our perspective on them is determined and limited by the place they currently occupy in the network. By discovering new interpretations, that place can be changed and new uses can be found. It is this freedom of interpretation that makes interactions with machines more than a monologue of the ancients and an actual dialogue with the networks that surround us. I'm skipping something. The notion of liberating machines is evoked by Gilbert Simondon when he explains the project behind his book Du mode d'existence des objets techniques, on the mode of existence of technical objects, from 1958. In the introduction, he complains that culture has a xenophobic attitude towards technology. To him, it is a mistake to oppose the world of technology to the world of culture. It is only a superficial humanism that conceals the reality of technical objects in which human efforts and natural forces meet and work together. I quote, "The machine is a stranger. It is the stranger inside which something human is locked up, misunderstood, materialized, enslaved, and yet which nevertheless remains human all the same." End of quote. According to Simondon, humans should be the permanent coordinators and inventors of the machines that surround them. In the midst of machines, humans operate together with them. He compares this relation between humans and machines to the interaction between musicians and a conductor. A conductor is not a master over a group of slaves, but organizes a society of musicians. And in this comparison, the conductor is capable of conducting because together with the musicians, the conductor is also performing the music and acts as the interpreter for everybody, of everybody for everybody. But it's not only the conductor who conducts. The conductor may act by slowing down or speeding up the musicians, but the conductor is also acted upon, for instance, sped up and slowed down by these musicians. And probably taking the cue from Norbert Wiener, who made the same remark 10 years earlier, Simondon contrasts such an approach with autocratic ideas of technology. If one thinks of the machine as serving to domesticate natural forces, the machine becomes a slave that makes other slaves, all in the name of human freedom. Simondon does not think this will work, and I quote, "It is difficult to free oneself by transferring slavery onto other beings, man, animals or machines. To reign over a people of machines that enslave the entire world is still to reign, and every reign presupposes the acceptance of the schemes of enslavement." In such an autocratic concept of technology, machines serve to enlist materials and forces for the benefit of humans. According to this conception, humans are free and machines are like slaves, like what Simondon said. And this corresponds to the problematic side, perhaps, of the cyborg, a creature that was conceived within military-industrial complexes as the fusion of humans and their technology, extensively discussed by Donna Haraway. Oops, this is Simondon, this is Donna Haraway. But Haraway considers that the cyborg, as an illegitimate child, has the capacity to wrestle itself free from these origins. She wrote, and I quote, "After all, the fathers are perhaps inessential." End of quote. I've said already that I see media archaeology as a method to investigate the collective body and mind that we have constructed by shaping our environment and by surrounding ourselves with technology. I believe that producing films, installations, and texts are small gestures that may help to shape this collective construction. We can only hope that the cyborg is able to pry itself loose from its schemes of enslavement through writing and making art.
Thank you so much. Well, as part of the laser format, we'll transition to have a little more of a conversation They're together, and we of course welcome questions or thoughts from the audience, but as always I have some things to go. So please feel free to have a seat. I'll hand this mic to Waryoung if you want to start us off, and then I'll grab the other mic.
Okay.
Or I can start you off too, that's fine. I can start us off if you want.
Yeah, that'd be great.
Okay, well, Joost, thank you so much. There is so much that we can talk about, but I'd love to start a little bit more with you as an artist, and then maybe get into some of the philosophical things that you ended with, because that's so powerful and engaging and timely, of course, as well. I was curious, in your films, you touched on it a little bit. If you could talk a little bit more about the process of conception of a film. Do you have an end result in mind and then you start the exploration, or do you start with a different seed? If you could just talk a little bit more about the artistic process from inception to completion, that would be wonderful.
Yeah, thanks for that question. Yeah, I'm going to say something, but then I'm going to now say the opposite first, by saying that if I do a project, very often I write grant proposals, and then if I then compare the end result to the grant proposal, it fits. So it looks as if I'm doing what I had in mind, but that's not really the case. So I think I'm capable of writing it down in a way which is so flexible that people think, oh, that fits, and that I also think it fits. But very often my projects start with a principle. So in this case, you could say it started with this question, like if you use this analog computing technology, what images does that make? I mean, how? Sorry. So the question could be like, if you use this analog computing technology, what is the potential to make images with that technology? Which is a summary of a lot of other questions. But anyway, it starts with this kind of principle, and then starts a long process of exploration. I mean, I talked a little bit about it. So part of this exploration is building stuff, and then putting it to work, and then seeing what it does, and then adapting, and also discovering things. I mean, for me, this process is really about discovery, about unsuspected possibilities, all these kind of things. And then, so that basically means that if I talk about the process of a film lasting several years, I mean, most of my films lasted very long, like four or 5 years, then typically, if it's 5 years, 4 years would be exploration. Because it also sometimes includes learning, like in this case, I did not really know electronics very well. So it's also skill, like it includes many things. So that takes very long. And at some point, after I did a lot of explorations, I sit down and I make a score. I have a background a little bit in electronic music, so I've been brainwashed, one could say, with a kind of very formal approach to contemporary music. So my heroes when I was studying were Xenakis and Stockhausen, but that was really the environment. So my first films, I made like incredibly meticulous scores on graph paper. And they were basically animation scores. So my films were composed in that way, and then if it didn't work, I would make the composition again. I would not edit or adapt. And that's an approach which I still have. I mean, it has changed. So in this process, there's one aspect I didn't really talk about, is that this is all generated real time. So this generates very complex images, but all in real time. So there was a score, but the score, it's basically, the film consists of 18 sections, and for each section I set myself a task as a performer, you could say, and then I try to perform this task as well as possible, and then along the way also things happen. So you discover new things, and I cheat a little bit, not so much. So the task can also change a little bit. So I have this approach, and it's also because these images are synthetic. I don't really need to edit. It's not like in the sense of cinema that or if you make a documentary, it makes total sense to film many things, and then the editing is where it comes together. For me, the editing is only putting the pieces together which I've made according to the score. So I don't really edit in a traditional sense. So I hope.
Yeah. That's great. Thank you so much. It seems to be a very detailed and involved process in the creation of it. And my follow-up question is, again, something you touched on just a little bit is the audience and how you sort of kind of pull people in a little bit. I wondered if you might talk a little bit about what your desire or what your interests and what you want from your audiences that see your films, if anything, because I know that for some artists that's not necessarily the most important thing, and I'd love to hear a little bit more about what your goals, dreams, intentions for the audience are.
Yeah, that's a very good question, which I have not touched upon in any way in what I've talked about. I mean, one thing also about music, which I still, I think, incorporate in my films and in the structure, is that in sort of more classical forms of composition, there's this sense of introduction of the material. So you introduce the themes, and then after that you work on them. So there's a kind of didactic aspect to that. And in my case, what I do in almost all my films is there is also this didactic, that these elements, like say the formal elements, like the motifs which sort of make the visual music piece, are also sort of coincides with the principles I'm using. So it's also a way to actually explain what's going on. So my hope is that on a sort of non-verbal level this works, that people have associations, that in this way you sort of build up something, or that at least what I hope, for me the minimum is that they feel that they're entering a kind of coherent universe of images. That is more like a natural phenomenon than something where you see the hand of a composer going like, now this, now this. So that's for me something I really aspire to. And very often that happens. I try to achieve this by having this kind of introduction, by sort of seducing or drawing people into the world of these films. And of course they're abstract films, so that just the word abstract is already guaranteed to scare away half the audience. But they're also just visual, so in some contexts that's actually, if you just don't say that they're abstract films, then lots of people enjoy them. I mean, I've had many open air screenings where this, like a film of mine, would be sort of squeezed into a program, and people enjoy it. I mean, because it's also very direct. It's like music. But then the last film, it's because it's so long. It's a bit of a different story, because 80 minutes is just very long.
I have a related question. In terms of your artistic practice, I was so fascinated by this analog computing. It's very, very physical and tangible and haptic quality, right? And then the outcome of your work is very abstract. And I was wondering, like, as an artist, like if there's any kind of correlation, you see like a physical quality that you enjoy, like to create the abstract images.
Yeah, for me, I think there's two ways to look at abstraction. Like, there are many ways, certainly, but there are two perhaps ways which are common. One is to see abstract entities as ideals which float in some kind of weightless universe, and another way is to look at abstractions as things which are general, but which are very present around us. So, for instance, in this very first piece, the reason this was, I think, one of the first pieces. So it's old; it's more than 10 years old. Where I started using soundscapes of sort of realistic sounds, like field recordings, as a soundtrack to my images. And one of the things I really liked about it is that it anchors these images in our physical worlds. Because for me, and I think that's again the effect of the word abstract. Like for me, these images are very sensual and very embodied. And for me, it's like, for instance, if I think about the history of experimental film, you have people like Stan Brakhage who make the connection between the images they make and the images you see when you close your eyes and your eyeballs. Like this kind of noise which is generated by your body. So I think a lot about the body when I make these films. Like it's for me, these are images which we somehow know, and but they don't represent in the way that a camera represents. Does that answer your?
Yeah, yes. One follow-up question. I was wondering, like, you have also like collaborative works with other like performers and technicians as well, right? So if you can talk a little bit about how you work with other people collaboratively.
Can you repeat that, Claudia?
Oh, sorry.
Yeah, what was the question?
Oh, I'm sorry. Was it microphone? My question is, like a collaboration. Like how he works with other artists and like theorists or other people.
Yeah, that's very different in different ways. But perhaps to latch on what we were talking about before, one thing would happen when I started collaborating with dance companies. I collaborated with 2 different dance companies, and one was a collaboration over more than a decade, and also doing like smaller, more like research type projects. Like dancer using sensors and influencing the music, but also the images. This kind of project, but also 2 operas, which were like huge productions, where then I did the set, let's say, the projected set. And what happened in my collaboration with this particular company is that when I started, I was writing code and generating images. So in a rehearsal, I would typically sit there with a stopwatch, and then I would see something and think, oh, this is great, and then time it, and then go back to the hotel, write code, render the images, and then the next morning I came with my hard disk. Yeah, let's try this again. And then they look at me and say, it's a good idea, let's try it again. But you should know, well, we have moved the order now, and this is now 3 times as slow, and we do this faster. And then I look at my hard disk and I go, so that's the moment where I started doing things real time. So I started making real time visual systems which generate images in real time to be able to match this and also to be able to improvise. And I still do also live visual performances, and now I have a system which I've been using for quite a long time, and it's a system which is the behavior is so chaotic that it's anyway more or less impossible to plan. So it's just, so I play mostly with improvised musicians, like people who are really also used to just having dinner but not rehearse before the concert starts, and then we play, and everything is completely improvised. So I really like also that as a kind of counterpoint to liberating myself from my Xenakist upbringing.
Yeah, great. Thank you so much.
We have tons more questions. Yes, Jen.
Sure. Thank you so much for the talk and for sharing all this work with us. It's really fantastic. My question has to do with the relationship between your work and institutions. And this crystallized for me when you mentioned seeking grants as an essential part of your creative process, right? The way this works into it. And so the first part of the question is to ask about the relationship between sort of the institutions represented by the military-industrial complex of the Cold War, right, that these machines are coming out of, and then the arts institutions or other educational institutions that are funding your work or are an integral part of your work now. How do these 2 points connect? And then a third point that it has to think about, of course, is the way that sociologists coming out of that distributed cognition thing think about institutions as well, because very often the notion of social institution is the location of where we think about that forms. So just institutions.
Yeah.
They seem to connect throughout. Tell me about it.
That's a very multi-layered question. But to start with a very concrete point, like the grant writing. I think I'm very privileged to be in an environment where this is possible, that you can actually write grants for this kind of project, which also means that these are project based. So that means also that you have to have in mind already an endpoint. For me, this actually shifted some time ago when I started to enter the world of research grants. So I just finished a PhD project, which is in Europe PhDs in the arts have a very different status in Europe than here. Like, it's quite recent, so it also means that people who do it are typically people who have already a kind of career of like 1 or 2 decades. So it's more kind of a way to go deeper or to change or to transform practice. And what happened with having a grant for research is that this process became much more open-ended for me. So there was nowhere in my application for this research project was the word feature was not mentioned. Like this is really something which just happened, even though I did do about half of what I promised I would do. So that's one aspect. The second aspect is a relation between these military institutions and or similarities perhaps or resonances and the artistic institutions. I think that's a really interesting question, especially in the media arts. I think there is an inherent tension between, if I look around also myself, like in media artists I know, between, and that's not perhaps directly related to the military, but more related to, like some of the funding for media arts comes from innovation, and that makes a lot of sense. But there's an inherent tension between innovation, which is also not invention, which is a different term. So innovation is about application, it's about implementing. So it's in some ways very functional. So there's a tension between that aspect of it and the aspect which is more, I think, invention, which is more open and more open-ended. And where I do think is also very important for these institutions that there are spaces where really different things can imagine. I mean, my example is always Alan Turing was solving a very obscure problem in mathematics by inventing the computer. So we need people solving very obscure problems in mathematics, and I do without thinking of what it's good for. And I do also think that artists can have this kind of role by radically questioning things. But it also means that they can be very critical. And for instance, there's now, I think, many examples of people working with VR or AI grants, artists being very critical and therefore not being able to be funded by innovation because there's tension. Like if you question the idea, should innovation be owned by big corporations, for AI be owned by big corporations, then of course these big corporations are perhaps less likely to give you money to research this question. So I think there's a lot of very interesting conflict. And for instance, in Europe you have a very interesting media art festival called Ars Electronica, which is funded for a large part by innovation money. So there is friction. I answered two of your questions, perhaps.
Kind of a follow-up to that from the institutional standpoint, you touched on in Europe some of the great festivals in media arts, and as we look ahead here as developing our media arts, interdisciplinary arts dialogue, and you've been in academic institutions, can you comment on sort of how things are going in Europe in that way from an institutional standpoint, and also any recommendations or things that you've seen that really work as we are developing these conversations here?
Yeah, good. Thanks. Yeah, it's a great question. Like one thing, I'm like in Europe, like I've been in academia, but it means something really different than here. Like I've been in an art school. I think that's more, and I've been head of a department in an art school. But that art school is in some parts of Europe. Those art schools are not actually part of university. So one thing I'm like, if you think about the interaction between art and science, one thing I'm always very jealous of what happens in the States is that art schools tend to be part of universities where there's also science. So it's in some ways institutionally much easier to bridge this gap, whereas we Europeans, we have to, we come from this very small art school which may have 2,000 students, and then we have to phone these people in these big institutions which work with millions of euros. And if they would like to be, collaborate on a project. So it's a very different dynamic. So that's really different. And on the other hand, I do think also that these smaller institutions also create spaces which are also can be also much more flexible and open-ended. So I'm still, for instance, surprised that the department where I came out of and which I became the head of later started as a place which was called the Interfaculty Image and Sound. And I'm still surprised how few intermedia or audiovisual departments there are in the world which are really informed by musical composition. Like it's very often audiovisual departments come from video art, from visual art, from cinema, but from music it's very rare. And we were very close to the Institute of Sonology, which is one of the sort of older institutions around electronic music in the Netherlands, in Europe. So we really had this, and I realized that that's unique, and I'm somehow amazed that that's still unique. Like this was a good idea in the 1980s or 1990s to do this, and I think it's still a good idea. So there is a kind of inertia, and of course, things have changed. There's many composers who also make imagery. I mean, like things have really changed. But still, if you look at moving image departments, I find it striking that there's, it's a time-based art. So why are there not more composers, and then not thinking about soundtrack, but really about, what this moving image is. As an example of a kind of interdisciplinarity which seems so obvious, and it doesn't happen. And then this was already 50 years ago. Or you could say, well, this was already a good idea 100 years ago, when cinema came. And I think there's many examples like that where things seem obvious, but they just don't happen because the institutions are just built in a certain way.
Yeah. Well, thank you for that background. That's super helpful. We are at the end of our structured time together, but we know everybody has different things to go to and all of that, but we would really love to close here officially, but invite everyone to please have some sandwiches, have some snacks, enjoy the bistro tables, and continue the conversation. You've probably come up with other questions or other threads that you like to pull on, and we'd really love to invite you to continue that. And so on behalf of all of our sponsors and everybody who has helped to put this event together, thank you, and we look forward to seeing you next month for the last one of the spring semester. So thank you, Joost and Woryong, and thank you to everyone for being here. Thank you.
Thank you.